Sorry about that. So here you can see you have the variable w, x, y is equals to, so now we know we have 3 variables. So this is gonna be our input, right? So what we do is we just draw some connectors. So on a breadboard, this might be a conductor. So we have our 3 conductors here, 3 lines. Then we know this one is going to be W, and then this will be our X variable, and then this will be the Y, right? So we can see that we're just gonna use the divide and conquer algorithm. Basically what we're gonna do is that we're gonna split this so that it's easier for us to tackle the problem. So W is inverted, X is inverted, and Y is not inverted, and this goes into a 3 input OR gate, right? 1, 2, 3. So our conductor will be here, then here by X, and Y, right? So W should be inverted. So there's basically 3 important gates here. Firstly is the OR gate. OR gate is basically your A or B. You can call it addition, right? And then we have your AND, your AND gate, which will be A and B. Then we have your inverter, right? So these are the 3 most important gates here. So inverter, if your input is A, the output will just be the complement. The complement of the input. Yeah, here it is. Okay, so what do we need to do? We know that W is inverted, so let's invert it. So we're going to invert W. We know X is inverted, so let's invert it. And then we take Y as it is. So all this, they go into a OR gate, 3 input OR gate, right? So we're gonna have our gate here. Have our 3 input OR gate. All right, so now we're here now. So here we have WX. We know, okay, there's a AND gate, right? WX, and then the X is complemented. Then we're going to OR it with the Y, and everything will be complemented. So start with WX. So let's connect WX. So remember, divide and conquer. So we look for the smallest part. We start from the lowest. So here the lowest is definitely WX and X complement, right? So we're gonna take our W. Then we take our X. So we know X is inverted. So let's invert the X. And then this and this, they go into a AND gate, 2 input AND gate. Great stuff. So we're done with this one. Then we know we need to OR this whole thing with this gate, right? With this variable. So we take Y. We take Y, and then it's gonna be an input into this 2 input OR gate, right? So Y2 input, this is the first input. and then this is the second input, right? So now we have wx naught plus y, right? Wx naught plus y. So, but we can see that we need to complement everything. So this whole thing we need to complement. So we can use an inverter here. Use an inverter, right? You can also just use a NOR gate here. So the opposite of the OR gate is a NOR, right? The opposite of a OR is basically a NOR, right? And then the opposite of a AND is the NAND, right? So what we basically mean is that for A, if it's A or B, for the NOR, it will be A or B, A or B complement, right? That's what we mean. A and B will be A, B, not. All right. So we have this one. So now we have our inverter. We have this one. So here we have three inputs again. W is inverted. So we're going to connect the inputs. WX. Invert W. So this is a 3 input AND gate. AND gate. So it's this gate here. Great stuff. So we're done with everything here. Then we see that this one and this one, they are ANDed together. So we need to AND this and this, right? With a 2 input AND gate. So this is one input of that gate. This is the secondary input, right? And then we see that these two are odd with this gate. Here is, guys. So this is the output of this AND gate here. And then this is the output of this AND gate here. We add them together, we get our F. So our output F. All right, thank you.